All right, good morning, everyone. So today we're going to be doing an intro to R. So again, if you're already familiar with R, this may be very basic to you. But if you're not familiar to R, I hope that this is an easy transition for you to start using R for everything that we're going to be doing this semester. So the way that we're going to work this on this course is we'll post new data, new scripts on GitHub. And I will let you know when I do that. And then, I ask that you retrieve those files from there. Because on this course, the goal here is not to use Git and GitHub as a version control software. I'm not going to really expect you to connect GitHub from the cloud to your computer or do anything like that. So the easiest way for you to download the data or the files is just by going to the repository that I share with you. So the 2024 PPA. And then, I'm sure you've done this already, but just to show you if you are confused, you can click on this green cold button and then just download the zip. It's going to download a folder for you that actually contains all the files here. And so I want to show you where that folder is on my computer. And then we're going to start perhaps a little bit today, but definitely next class, we're going to start setting up a very specific environment for as far as folders and folder organization structure for our files. But for now, what I have on my computer on my side, I want to show you, and maybe if you want to do something similar on yours, somewhere in your computer, you will need to have a folder for this course, right? So you can call it whatever you want. It can be Advanced Topics Precision Ag. I mean, really whatever you want. I'm calling this Programming Precision Ag because this is the actual name of the class that will be, right now I'm teaching under the Advanced Topics, but from next year on, it's going to be called Programming Precision Ag. So that's why I'm calling that. So, anyways, regardless of how you name this folder, you want to have this folder there. And I have here a copy of what I'm downloading from GitHub. So this 2024 PPA, yours may say main or have something extra on the name, but this is that folder. If I open it, these are the folders that I see in it. You, at this point, don't have all of these folders. You probably just see the packages, the 01 packages and the 04 class code. If you do not see the 04 class code, it's because you don't have the latest version from GitHub. So go ahead and go back there and download that again. And really, I want to take one step back here on my folder hierarchy because I want to show you. So this folder, 2024 PPA, I ask that you do not do anything of yours in there. I don't want you to be saving your scripts there. I don't want you to be really doing anything directly there. Right now I am on this main folder of our course. So what I want you to do is use this folder the 2024 PPA that we're going to be downloading frequently, just as a means for you to get the scripts and the data from me, but do not save anything of yours there. Everything that we do can be outside here. So let's go ahead and create if you already have this main folder for the course, and one of the subfolders is the one that you're bringing from GitHub, let's go ahead and create a folder here called 01 intro. So this is a folder that we're basically going to, well, I'll give it a moment, excuse me, for you to do that. Just to organize your folders. And again, one thing you're going to see in this course, and also I hope that you take this to your research, is that organizing folders and files in your research project is going to be really important, as the more you have, the messier it becomes. So having a structure in place is going to be helpful for you. Okay, so again, the 2024 PPA. So this is all inside of the main folder for the course that I have. Then I have the 2024 PPA that again is a folder that we're just going to be using to bring the data from the data encode to download things from GitHub. It's not a folder that you should save your own files there. Now, if you go on 2024 PPA that you just downloaded from GitHub, you should see the 04 class code. If you go in there, there's going to be this 0110 intro to R partial.r. So this is the script that I share with you is a partially filled script. We're going to co-develop further this script in class today. I want you to copy this. So if you copy that file, then go back on your structure, get outside of the 2024 PPA folder, and then paste this into your 01 intro. The reason is that now you're going to we're going to work with this partial one and we're going to edit it. And again, if this is the one that you will edit yourself and save on your computer, not the one that is in the 2024 PPA, since that one is this folder 2024 PPA is going to basically be overwritten every time I send you something. So that's why I do not want you to save none of your own work on 2024 PPA. Okay, so at this point, you should have been able to, so first download that 2024 PPA from GitHub, and then go in 04 class code, copy this file that's in there, go back, paste that file in 01 intro, and have that file right here. This is where we need to be before we get started. Anyone needing help? Yes. From GitHub? Let me go check. Yeah. Is that, do you have a summary? Actually, yeah. So I just want to show it again in case this could be helpful. So if you are on GitHub, you're going to click on that code green button and then click on download zip. So this is going to be a zipped folder with the contents that we see up here. And that's how you get the materials. Online, is everyone following along? Any questions, any problems? I don't hear anything, so I'm assuming you're all good. If you do run into issues, feel free to unmute yourself and speak up anytime.
Yeah, doctor. I download the PPA main, and I have this packages 01 packages and 04 class code here.
Right.
And then I click on 04 class code, and then I have something called README MD. Yeah.
Okay, so let me show you here what you should be seeing. So so on my 2024 PPA, I have a few more folders, but you should be seeing the 01 packages, the 01 class code, and the README. So if you click on 04 class code, it should not be a README file, it should be this file.
Okay.
Is that what you're seeing?
Yeah, but I guess it's just but it when I click on intro R, it won't open.
When you click on this file, okay, so I guess for right now we have not done that yet, right? So the goal then is just for you to copy this file from the 2024 PPA main and paste that into a 01 intro folder that we just created and have it right here, right? So the next step is actually going to be to double click on it. And if everything worked all right, you will open up your R or RStudio software. But I guess before we click and make sure that it opens so we can see on my side as well, I just want to make sure that everyone was able to get to this point. Okay, so I'm assuming everyone was able to get to this point. So now, if you do double click on this script here, it should launch your RStudio like it is doing for me. So if you want to go ahead and try that, double click on that and it should launch your RStudio. My RStudio may look a little bit different from yours. Just the color and maybe the location of things, but you should have the script loaded somewhere on this part of RStudio. So if you did double click on it and it did not prompt RStudio to open, let me know, because then something's going on. Did that work for you, Rolando? No?
It didn't open. No.
Okay, so another way, if it didn't work for you, another way that we can try is to basically launch RStudio by itself and then open file from RStudio. So if you know, so let's say if you just open RStudio, it would look like something like what is showing up for me. Maybe the colors are different, but still, it should be something like this. And then you can go file, open file, and then you just browse to wherever that is. Remember that this should be the script in 01 intro. You just click on that and click open. It should have the same effect. Any luck there?
It opens something way different than that. Well, I guess it's because you have it on dark, and then you have the window reduced, right? I have a lot more here.
Yeah, well,
You have some boxes to your right and left.
Can you like on your side, can you at least see the script that looks, so you should have opened a tab here with that script name. And then this, I mean, at least some of this, the text should be the same. Are you seeing that?
Yeah.
Okay, awesome. Yeah, so as long as you can see the script, that's great. You know, it looks different just because I have customized a little bit how my RStudio looks like, and I'm going to show you how to do that on your side in case you want to do that. But yeah, as long as you can see the script, that's what we're aiming. Is everyone here, Nathan's able to see your script like similarly to what I'm seeing here?
Is that what you have open, that's RStudio or that's all?
So this is RStudio, the whole thing.
It's just pulling up in column. I'm at the wrong one.
Okay, so let me come check.
This is what's pulling up here, but I just tried to put it down. Oh, yeah, so did you install RStudio? I did, but I don't think I installed it right. So I just had to download it when it was on Macs. Okay, so I'm trying to download it.
So what happens if you do a search for RStudio? Does that pull up anything? Right on your computer? Yeah, I mean, so if you install, it will come up here as an icon. I don't think it was actually installed, because I think here, where you can directly to install, you have to drag that into your, go back to this folder here. Behind the search, you have to drag that into your applications to actually install. So maybe it was that. So let's do this, while you, yeah, if you just, I don't know if that actually installs or not. I think you have to like drag and drop that into the application folder.
I clicked on that and nothing was there, so this is kind of in mind.
Yeah, I mean, so this is our studio right here. Well, so we do have that, I think now I'm not sure what you put here. If you just install that, this is our studio, right? So now if you go to that 01 intro and go like our scripts, it should open up. You want to try that?
Oh, I got this.
Okay, so I'm gonna get started because at first it's just some explanation of things.
Okay.
And when we get to the actual coding part, let me know, just tell me time or help, and I'll help. Thank you. Everyone else here good? All right, so if you double click that R script and it opens R, which does not look like RStudio, then it probably means you did not install RStudio. So you're gonna have to do that. So I guess here in Athens, we're figuring things out. Online, I guess let me ask this way, does anyone need help to get into this stage? Because it is, again, this is a live coding class. If you're not with me here, you're not gonna be able to follow along, and you're gonna have to catch up later with the video. But I'd rather have you fix issues now. Now, it is our first software class, so it's okay if we have issues, and we can fix them here. So anyone online needing help to get to this stage? Okay, I don't see anything, so I'm gonna move on with the script here. Okay, so you may be seeing something like this, where you have this part below the script here. I'm just gonna minimize that so we have more room to see the actual script, and I would just gonna increase my font here so you can also see. Okay, so this is our introduction to R. First, I just want to remind you that this is the website for this course. I would highly encourage you to bookmark that because you're going to be referring back to that a lot of times. We will have all of the code and data distributed through GitHub, as we already shown earlier. So every time I give you a new partially filled script, that's where we're going to get that script from GitHub and downloading the way I showed you. Whenever we finish a given class or a given exercise in R, I will post a completed script as well. So of course, you're going to have your own completed script because you developed that in class with me. But in case there's something that you missed, or maybe something that you want to see the final version from my side, I share that, however, only at the end of that script, when we finish going through that script. And that's also going to be through GitHub. And then, we have the recordings on YouTube. So what I'm doing is basically recording each class, and as soon as I get to my office, I upload that to my YouTube channel, and it's going to be there. And then later in the day, I add a link to the recording on the website schedule. As if you recall, there is on the schedule, there are links for code, slides, and YouTube recordings. So if you want the freshest, if you're anxious to check a recording, if you go straight to the YouTube channel, if it has been uploaded, it's going to be there. And only later in the day, I update that link on my website so you can also have a reference. Okay, so before we really start talking about a lot of different things about R in RStudio, I just want for us to take a moment to set up our RStudio. And so there are a couple of things that we want to do here that I want to go with you. So the first one is, so R by default, it saves your workspace from one session to the next. If this doesn't make a lot of sense right now, don't worry, but I just want to tell you that we do not want that to happen, and that is the default behavior. The reason for that is a lot of times you're working on a project, you're creating things with your code, and then you're done for the day, you come back the next day, and you have that ghost of what you already worked on the previous day on today's work. And sometimes that's good. A lot of times that's not good because you may not know exactly what you did, and then you're relying on objects that you don't know how they were created. So again, if you don't understand what that means for at this point, don't worry, you will in the very near future. But for now, I just want to change that behavior. So we're going to do that right now together. So please do this on your side as well. So in our studio, you're going to have this tools menu on top. You click on global options. It's the last item in that list. And then we go on general workspace. So general here under workspace. I think yours this box may be checked. I have already unchecked mine. If yours is checked, please uncheck that. And then you can say here never as well on this this drop down menu and click apply. Excuse me. So again, just gonna go through this again. Tools, global options, under general workspace. Sorry, I need it. Got the simple one. And then uncheck that, click apply. And then the next one is I want to show an outline of the script, and this is something that you're going to see soon here what that means. But to do that, excuse me, we go, is it on the same window here? So again, tools, global options. We're going to click on R Markdown on the left here. And then show in document outline. Let's see where that is. Show document outline by default. That should be clicked. And then here in show in document outline, you want to have it to sections and name chunks. You also click apply and then OK, and you should be set up. Give me just a moment. I'm just gonna get some water. But if you were not able to follow along, you can just follow these instructions here, and I'll be back in a minute.
Yeah, I had it down.
I had a problem too, like when I did it, the R opens it, but when I right click on the file and then open the R studio. I think
I think I. That would be.
it should be really.
All right, sorry about that. We're back. Okay, so now that we have set up things in our studio, I want to just talk about the learning objectives for today. So first is going to be to get familiarized with R in our studio. We're going to learn about terminology and syntax, so we get familiar with how things work. We understand different object types. So every language, or maybe not every language, but R has objects. That's basically how we save things as we're working through our script. So we're going to talk about some different types that's going to be important for you to understand. Then we're going to create a simple data frame and explore it with numbers and graphics. And also learn about our studio projects. We're going to create your own project and set up proper subdirectories. All right, so just beginning here, why R? So R is one of the languages that is open source. Another option would be Python. But I personally use R and like R first because it is free. A lot of students, as I am, I'm from Brazil, there's always an option for you to go back and work in your home country, or even if you're from the US but you work abroad, you may not have access to some proprietary software. I know during my master's I was using SAS, and I know that in Brazil, SAS licenses are expensive everywhere, but in Brazil and other developing countries it may be difficulty because the funds for that type of thing are even less available. And so working with free open source software is beneficial in that aspect. Also, R runs on multiple platforms. We see here in Athens, we have people working in Windows, we have people working in Macs. If you work on Linux, that also works there. Other software, for example, SAS, ArcGIS, others do not, right? You have to have a Windows PC. If you don't, there are ways around if you have a Mac, but it doesn't natively work with different platforms. The online community and support for R is really, really big. You're going to see as you start learning R and you just Google how to do this in R, you're going to start seeing that there's a lot of resources out there, very easy. A lot of times, if you ask Google the right question, you may get a resource that is exactly what you're looking for, which a lot of times other proprietary software do not have that type of community. And also, as you're seeing here, R is the language. RStudio is a software that comes, separately from R, but complements it very well. And RStudio itself is a big company that has many scientists that produce a lot of very great packages and have also a very nice community behind it. So just that community aspect is really important, and as you're going to see, the more you learn. Also is continuously under development, right? So what I mean by that is you're going to learn about some of the terminology here. R has different packages that you already installed. Most of those packages are developed by people, that learn R, find a application that they see a need, and they go and write a package and make it available for others online. So there's always something new coming out. Actually, just from last year when I taught this class to this year, I'm updating some of the packages that I'm teaching just because more things became available, easier, better. So always under development, and also because of reproducible research. We talked a little bit about this, I guess, in our first class, and this is not just R, it's any programming language that you use for data analysis, but I always tell this example that I think is really interesting from a reproducibility standpoint. So there was this team at Duke University that they work in the medical sciences, and they published this paper developing an algorithm that would basically take data from cancer patients and make a recommendation of what would be the best treatment for that patient. It was a huge breakthrough at the time. A lot of hospitals started using that algorithm, and it was becoming widespread and having an impact on patients, and hopefully for the better. However, a different team at a different university decided to ask for the data and the code so they could try to reproduce that same algorithm, that same results that they created. And long story short, they were not able to. It was basically, they found out that they were only able to come up with the same model to predict cancer treatment after making deliberate changes in the data, in the code, making changes that should not be done. And so that those researchers at Duke were under very high scrutiny. And then they realized that, an undergrad was playing with the data and changed columns in Excel without telling people. So change the values, but not the column headings. Not just the undergrad, but the whole team that was working with the data were making so many mistakes, one after the other, all in Excel. that they were not tracking it, it was not reproducible, and in the end, they came up with this great algorithm, but that was actually not right because it could not be reproduced if you were using the right data and right code. So, of course, we're not working with human patients or human subjects, we're working with plants, but nonetheless, we want to make sure that we're using the right data, the right way, in a reproducible manner for us to do the best research and apply that as we can. So it's just, one example of how reproducible research is really important, and R is one of the tools that helps us with that. Okay, so that's a little bit about R itself. Now, why RStudio? So RStudio is an IDE, is an integrated development environment that has multiple components of an analysis all in the same folder. So I don't know if you even did this, but if you just launch R by itself, come through here. So if you launch R by itself, R is just this window. That's what R is, right? So all of the computational resources and all of the interpretation of the code happens within R itself, but R itself is not very much friendly. So imagine that this is R. When people were working directly with R, they would have to have another like text file just for the script. If you create a plot, it would be displayed in yet a third window. So it was not very friendly to do an analysis altogether. And that's where IDEs like RStudio come into place. So RStudio, if we just take a tour here of RStudio, basically what R is, so that little R window that I showed you, that's what it's this on the console. This is the R console, is where code goes to be interpreted, and that happens here. But then RStudio combines other important aspects of an analysis all in the same window. So one of them is your code, right? So your code is going to live somewhere up here. We're using a .r file. That's an R script. That's where we're going to be coding. And this is where you write the code, but then this is not where the code runs. You have to send that to the console for it to run, and that's where it actually gets interpreted. So we have here the script, here the console. On the top right here, we have the environment. So as we create new objects within this session, they're going to start appearing here. And the last panel here is a really important one. I just want to call your attention to this because it has different tabs, and those tabs are really important. So right now, the Files tab may be showing you where your file is. There's also a Plots tab that if we create a plot, is going to appear here under this Plots tab. There's a Packages that shows the list of packages you have. If you ask for help for a given function, it's going to appear here, and so on. So it has a whole bunch of tabs, and these are the four main components of RStudio. I want you to get familiarized with them because, if you understand them well, it makes sure that you're doing the right thing. So I could write code directly on the console if we want, and I'll show you that in a second here as we start coding. However, that doesn't get what you're coding doesn't get saved. The console does not save your code, and that's why we want to have a script here where we actually develop the code and save it, and then when we run it, that basically it sends that line of code to the console to get interpreted. Okay, so I guess I skipped a little bit here, but just coming back. So another thing that I like about RStudio, so it does integrate all these components of an analysis. So the script, the console, the plots, the objects all together. It has color syntax, which is, you're going to start realizing it is really helpful, and you're going to see more of that when we actually start coding. And it has syntax suggestions. So what I mean by that is, if you kind of know what function you need, but you don't fully remember the name, you can start typing that function name. So let's say I want to take the mean as a function for mean. It gives me suggestions here, right? So, okay, there's this mean function, that's what I want. And then once you find the function, inside of it, there are arguments that you can also hit tab and then get the list of arguments that you can choose from. So this is something that RStudio does for you. If you work straight out of R, you do not get that. So these are some of the reasons why we use RStudio to work with, and we're going to be using that for the whole course. Okay, so now we're gonna get into the coding part. Doug, were you able to do that? Okay. Everyone, I mean, if someone still needs some time to catch up to get to this point, please speak up and let me know. If I don't hear anything, I'm gonna assume we're all good and I'm gonna keep moving. All right, I'm gonna keep moving. So let's talk about some of the terminology here. So one of the things that can be used for in a very simple way is just as a calculator, right? So let's say if I just want to type a number here, I'm just going to type 45, and please go ahead and do this on your side as well, because I want you to have the final script version. So if I just type a number 45, and let's say if I wanted this to be interpreted by R, one thing I want to teach you today, and this is, you're going to use this every single time you work in R, is how do you send this line of code from your script to the console? A very quick shortcut that I use a lot is, at least on Mac, is to hit Command Return. If you are on a PC, that may be Control Return. You can try, or in return is Enter as well. So Command Return or Control Enter. And you see that it's sent to the console because it appears here. So if you have your cursor blinking on the line that you want to run, you just push Command Return and then it sends to the console. Okay, so, just a number, but now let's do a little bit of math. So let's just do, you can go on the next line here and just type that same number, 45. Let's divide that by 13. So divide is just, the mathematical notation is just like Excel. So you should be familiar with that. So if we run that, notice that now, so it sends the code to R and then R responds back with a result, right? So when we just sent a number, the number appeared there, but nothing, we were not asking for anything to be done with that number, but now we have a division here that R interprets and spits out the result of that division, right? However, let's say I know, I can see on my console what's the result of that division, but if for some reason I want to use this number for something else down the code, I have to assign this to an object. So let's do that right here. I want to call this object A. So I just typed the letter A. The way that we assign something to an object is by using this notation of less than dash. So we refer to this as the assignment symbol, or maybe the gets symbol. In R, it also works if you use the equal sign, one equal sign. I prefer this less than dash because it's unambiguous. So I'll be using that just so you know. So let's say if I want to assign the result of this calculation to an object A, I basically just paste this on the right side of that assignment symbol. If you run this, so if you have your cursor in this line and you hit Command Return, so notice what happened here. So it sent this to the console, but the console did not give me anything back. However, notice how A now is appearing on your environment, right? So that A is an object that has the result of this calculation saved for you. So now if I want to assess that value, that object, whatever is in it, I can just print it. So to print an object, we can just type its name and then send it to the console and run it, right? So just call A and then I push Command Return. So notice how that sends it to the console. The console understands you're trying to print it and then gives you that result back. So this is an object. An object is something that you assign a value to it, and then you have to give it a name. So the name comes before the assignment symbol. You assign something to it that comes on the right side of that symbol, and then it gets saved on your environment, and you can retrieve that in the future. Okay, so let's say now that I actually want to save a few numbers instead of just one to this new object called B. So let's go ahead and give it the assign symbol. Let's say I want to save the numbers 10, 15, 5. So if I run this, I'm going to get an error. And you're going to get an error as well. And what's happening here is that whenever we are giving multiple values of something to an object, we need to concatenate those numbers together. To do that, there is a function called C. C stands for concatenate. So if you say C, open and close parentheses, just like I have here, this should work. So if you run this now, you should not get any errors. You will notice that now there is a B value on your environment, that's the object. And if we want to see what is inside of that object called B, we just type B and run it. So it goes to the console, and the console interprets that we're printing it and tells us what's inside of it. So an object can carry a number, it can carry multiple numbers, it can actually carry anything in, I mean, I guess I'll leave it at that and not make it complicated, but an object can be very simple, it can also carry very complex information. So let's get to this next object here that I'm calling C. I wanna now, instead of a number, I wanna assign a text value to it. So let's use the assignment symbol, open and close quotation marks. That's how you properly give a text or characters in R. And let's write precision ag. So if you run this, that goes to your console, it appears on your environment. And now if we just print it by just calling C and then sending that to the console, it's going to return the word precision ag, or the sentence precision ag. So notice how we started very simple with just one number, then we assign 3 numbers to this object, and then we assign a word to the object called C. And then we have all those objects on our environment right there. Okay, so these objects are very simple, right? They're just carrying the simple information, but in R it's very common to have objects that are data frames, right? So I want to create a data frame here with you and save that to this object called D. So let's go ahead and give the assignment symbol. And let's use a function that's called data.frame. And notice that as you type, you get that suggestion pop up there. That's the syntax suggestion from RStudio. The first column of this data frame, I want to call it number. So you can just say like that. I use one equal sign symbol here, and I want this column to have the values that are in B. So I say number equals B. So this basically is gonna see what's in this object called B and assign that to this column that we're naming number. So if we add a comma here and hit return just to break the code and make it easier to read, I want to create another column in this data frame that I want to call ID. And I want to say ID is going to be equals to C. So C, if you recall, is just the sentence precision ag, and I want that to be this column here. If you go ahead and run this, in case you got an error, make sure that you have your comma here, make sure that your parentheses are closing. Those are the most common places where mistakes happen in R, is missing commas or parentheses not closing. But if you did not get an error, if you ran smoothly, now we can print D by just running that. So it prints for us on the console this. So we see here that because we have 3 numbers in object B, it basically took those 3 numbers and listed them there. And notice now what happened with C. So with the object C, we only had one value, right? That was precision ag. And what R did for us is basically recycle that one value and just repeated that for each one of the rows to match the same length of the numbers that we gave that were 3, right? So this is basically how a data frame would look like in R. Of course, this is a very simple one. Imagine any data frame that you work in Excel would be just as easily handled in R. So data frames are going to be one of the main object types that we're going to be using in just to let you know. Okay. So the next object class that I want to show you is called a matrix. To tell the truth, yes.
I can't get it, it's not cinnamon like that down. It just keeps like dropping from 60 to 60 to close parentheses, it's not cinnamon all the way down to the.
Okay, let me come check here.
No, I mean, what happens if, well, you put it there? Oh, so it's command return? Yeah, yes, there you go.
Yeah, so just a reminder here for you. So let's say if I want to run this whole code here, I can have my cursor anywhere within these 3 lines of code, and then I run command return in max. That what sends it to the console. All right, so the next object type is a matrix. This is probably the only time that you're going to see a matrix in my course. We're not going to use that ourselves. There's a lot of matrix computations that happen behind the scenes, but we never see that. But I just want to make you aware that R also handles matrices in case you need that for some other reason, besides our course. So let's just create a quick matrix here. Let's come to this object called E. Use the assign symbol. The function that we use to create a matrix is called matrix. And matrices do not, so one of the differences between a matrix and a data frame is that matrices do not have headings. They do not have column headings, right? So what we're going to give here is, I want to give the object B 2 times, because so B has 3 components. I want to make a matrix that has those components repeated. Because we're going to give B 2 times, we need to use the function C, that stands for concatenate. So I just want to say C and then give B a couple times inside of that. After you get outside of this parentheses of the C function, I want you to add a comma. And then there's an argument for a matrix that is called ncol. That's the number of columns. I want to say ncol equals 2. So if you go ahead and run this and print it, you should see this output on your console. So notice how what it did is it basically took the object B that had the values 10, 15, and 5. And because I said I wanted 2 columns, it gave me 2 columns of a matrix where B was repeated for each one of those columns. Notice that this different notation that R gives you when it's showing you a matrix. So it gives you a position for the columns, a position for the rows, but it does not give you column names or row names because a matrix doesn't have those. Again, we're not going to be using matrices on this course, but I just wanted for you to be aware of that in R. Okay,
Professor, I have a question here.
Yes.
Do you have a second?
Yeah.
So I can run my script, but on the console, I just can see the orange thing. I cannot see the value, the white thing.
So it's not printing this for you?
Yeah, it's not printing this, just the yellow thing.
Okay.
The orange one.
So on your console, are you seeing this symbol here? This greater than symbol?
I do.
Okay. And interesting.
That's kind of, it's sending that down, but it's not giving me any of the other stuff you have. It did it the same for up
It
here.
did here, right? So, okay, so let me see here. So, Vinicius, so let's say if I run this piece of code here, right, it will send it to the console. But because I'm not asking to print, it's not printing. So if I want to see what's inside of that, I need to run the name of that object by itself, and that's what prints it.
Okay, let me see. Okay, that's the problem, sorry.
Okay, no worries.
Okay.
Yeah, and that's a good question because I think Doug was having the same question as well. So is that right, Doug? Yeah, so,
Yes.
yeah, perfect, awesome. No, good question.
Thank you.
All right, so the next one we're gonna explore is a list type of object. We will work a little bit with lists in this class. If you're taking my data science class, we're gonna work a lot with lists there. So this is a more common object type to work with, but I just, even though in our class here, we're gonna use just a little bit, but I want to make you aware because that's an important type in R. So to make a list, let's come to this object F. We give it the assignment symbol, the get symbol, and we use the function name to create a list is called list. Very intuitive. One of the differences between a list and a data frame, for example, is that a list can carry different types of objects inside of it that is not fully handled by data frames themselves. So to give you an example here, I want to create a component of this list called number that has to be in quotation marks. So we say number equals to A. So if you remember, the object A only had the result of that computation. So I want to say number equals A. I hit a comma. I'll open and close quotation marks again. I want to call this next component of the list numbers, so plural. I say numbers equals to B. If you recall, B has 3 numbers in it. I give it a comma. I want to hit return just to break the code and make it a little bit easier to read. So if you want to do that, your cursor should be right here. The next component of this list, I want to call it word. So I want to say word equals to C. If you remember, C was that precision ag sentence. Add a comma. Lastly, I want to create a component called data. And I want to say data equals to D. If you remember, the object D had a data frame. So now if we run this, let me show the code still. So remember, we first run it, so R interprets and creates that object on your environment. And then if we want to print it and see what's inside of it, we just call again the name of that object. So if you printed the name of that object, you're going to see that it has the components that we created. So it has a number component that only has 1 value. It has a numbers component that has 3 values. It has a word component that has a precision ag. Then it has a data component that has the data set that we created above. So lists are useful because they can create different parts of it, can have different number of observations. They don't have to match like a data frame has. Okay, so before we move on here, I want to show you a very important function that, at least to me, the more that I code, the more I realize this function is very simple, but very important. So we talked about here object types, object classes of data frame, matrices, lists. And sometimes it's important for you to understand what is the class of a given object, or if we're talking about a data frame, what is the class of a given column in the data frame, so we know how to use it and how I can use it. A function that we use to learn that is called class. So this function called class tells us what is the class of a given object. I just want to try here the class of F. Remember, F is this list object that we created. If I say class of F, it's going to tell me that the class of F is a list. So that is how R is interpreting this object is as a list object. This is important because different objects have different ways that interact with R. And a lot of times R may be interpreting your object in a different way than what you intended. And so by knowing how to understand how R sees it, it helps us to then decide if we need to change the class of that object or not. Right now, we're not changing the class of objects. I'm just showing you how to find out how R is interpreting that object. Okay, so one of the differences here with F is that F has all these different components, right? So we know that these different components are not lists themselves. The combination of all of them into the object F is a list. So what if I want to know how R is interpreting one of these columns here? Maybe the number column. Let's say class, again, of F. And then the way that we So imagine that this works both for lists and for data frames. If you call the object name of the list or the data frame and you want to go inside of that to retrieve a specific component of it, we use the $ notation. So if I say F $, it already shows me what components there are inside of that list. So let's say if I want to know what's the class of that number component, right? So if I run this, I see that R sees that as numeric. So numeric is one of the ways that R calls just like a number would be a class numeric. So I just wanted to show you this, how you would learn how R is interpreting something. Okay, so let's go to the next part here. So if you have your cursor after this function section here, what I want to do now is just explore some functions, and so you understand the concept of a function and how you can learn more about it if you need to. So let's use the function mean, okay? So the function mean, as you may imagine, it's going to return you the mean of a series of numbers. This is a function that we use a lot. We're going to use a lot in our class at different moments. So let's say if I wanted to know the mean of the object B, right? So I can just say B right there, and it basically sends this to the console, and then it shows me the result. So the mean of B, so if you recall, I'm just going to print B here. So B has 3 numbers, the mean of those 3 numbers is 10. So this is what this function is telling us. So we know that a function is a function because it starts with a word, and right after that word, there is an opening parentheses, right? So we know it is a function because it has that opening parentheses that eventually has to close. So here we see very, very easily that concept. Now, inside of functions, there are arguments. So arguments would be some options that we have to change the behavior of a given function. And so here, this mean function, so if I type again mean, it has this argument called x that it is telling me here on our object. Currently, there are methods. Let's see. Okay, this is not very helpful actually. But x is just whatever object you want the mean of would be that value of x. So x here equals b. It would be the same result as if we just say b right there. So then you might be thinking, okay, so why do I even have to say x equals b if I get the same results? So let's explore this function mean a little bit further. Anytime you have you are unsure. So let's say you know a function you want to use, but you don't remember exactly the behavior of that function. What do you need to give the function for it to work? We can get help to learn that. So there is this function called help that we can just open and close quotation marks. And because we want help of a function that's called mean, I just want to say help mean. If you run that here in one of your tabs in R, that's called the help tab here on the lower right side of your RStudio IDE, we get all the description of this function, right? So it says here arithmetic mean, it gives us a description. And then you get into the arguments, right? So this function actually has 3 arguments that we could change the behavior of. So x, again, is the object that you want the mean of. It has this option for trim. That basically, I think here is just a way to, let's say if you have 1,000 values, it's just going to trim the bottom or top side of those values in case you have outliers. I don't really use this often. But it also has this argument for na.rm that stands for not available remove. So a lot of times we have missing data, and that missing data may create an NA on a data frame, and that can cause issues. And I do want to bring this up because every time you use mean, minimum, maximum, median, standard deviation, coefficient of variation, those functions that represent like statistical summaries in R, they're all going to suffer from something you're going to see next year. So I do want to point that out here. And again, a couple concepts that I want to just reiterate again. If you know the function that you want to use, but you just like, I don't remember how to change the behavior, you ask for help mean, you get the help right here. If you don't even know what function you need, that's when I go to Google and I say how to do this in Google, or how to do this in R in Google. And then I find a resource for that. But I use the help a lot if I know the function, I just want to remind myself what are some of the arguments I can change. So what I want to do next that is going to show you the argument side of things and also this NA remove side of things is let's create another object that I want to call B2. So B2 is basically going to be, let's use the C function, the concatenate function, and give again the same value. So 10, 15, 5. And then lastly, let's give it an NA. So it has one more value here that's going to be NA. It has to be uppercase. That's how R knows that is an actual NA. If you do lowercase, it's going to think it's an object, and we don't have an object called NA, so it's going to throw you errors. Make sure NA is uppercase. So why am I showing you this? For a few reasons. So in your data, you will have NA values for sure, right? So either because a deer harvested your plots before you did, hail damaged your plots, I don't know, whatever it is that you were not able to collect that point of data, you're going to have an NA in your data set. And so it's important for you to understand this concept. So let's just run B2. You should see that on your environment. If we printed, we should see now the values 10, 15, 5, and NA. So let's go ahead and ask for the mean of B2. Just like we did before with mean of B. So notice now that the mean of B2, the result of that is NA. This is a very, very important issue here because every time that we have NA in one of these statistical summary functions like mean, median, minimum, maximum, and so on, if you have an NA there, the default behavior of those functions is to have na.rm, or in other words, remove NA equals to false. So they're not going to remove the NA from that list of numbers, and you're going to get in a return of NA as a result of that calculation. So how do we change that behavior? So if we type again the mean function, I want to say x equals B2. If we give a comma, we know there is this argument called na.rm. So we're just going to come here and say na.rm and say equals to T uppercase. That stands for true, right? The opposite of that would be false, which would be uppercase F, which is the behavior, the native behavior of this function is na remove equals false. So it's not removing the NA before it does the calculation and returns NA back to you. So we want to say NA remove equals to true and run it. So notice that now when we change this behavior of this argument to true, so remove NAs before you do the calculations, B2, the mean of B2 comes back as 10, which is the same as B before. That did not have the NA. Okay, so one thing I want to call your attention to here is I explicitly call the argument names here, right? So X was an argument, NARM was an argument of this function. Notice, however, that NARM is the third argument in this function. It's not the second one. So if I come here and I just say, and you can type along with me as well. If I just say mean and I say B2, so I don't specify X, I just say B2, and then I say T. If I run this, it's not going to work. Because since I did not explicitly call out the name of the arguments, it is filling them in the order that the function understands. So X is assigned is equal B2, but this T is actually being assigned to trim, which is not what we want, right? So I'm telling you all this because if your understanding arguments in a function is important, a lot of times we're going to be changing arguments. If you're changing the argument in the same order as it appears here on the help, you don't have to specify the argument name to change it. However, if you're changing the argument not in the same order, so in this case here would be the third place would be an ARM, then you do have to call out the name of the argument to make sure it is doing what you want it to do. So another example is, let's say if I wanted to get the mean and the first thing I say is true and then B2, that would most certainly not work either. However, and the last part of this little section here is let's say I do, for some reason, you do want to give that true argument as the first argument, you can. However, you have to call the argument name, right? So if I say mean na.rm equals true, x equals b2, this will work because now you explicitly called out the name of the argument. And in that case, it doesn't matter which order you give it. It just matters if you do not call the name of the argument. So remember that functions is normally a word followed by a parentheses. That's how you know that's a function. Inside of functions, we have arguments that we can change. And to learn what arguments you have available to change, you ask help of that function and then export that below here. And just one last point related to the help function here. So the help function works for every function in R. It will always give you a description of that function. It's going to show you the arguments of the function. And so give you the name of the arguments and also a quick explanation. It's going to tell you a little bit of the value that you get back, how that's calculated, how things are done. It may give you a paper reference in case that is something that was based on a paper. And normally it gives you an example at the end. So the example, a lot of times I use this part a lot because if I want to understand how to use this function, I can see that on the example. Okay. Any questions at this point? All right, I don't hear anything, so I'm going to keep moving. So on the prep material that you followed for this class today, you were asked to install some packages and then to load those packages, right? I want to make a distinction here. In R, there is a difference between installing and loading a package. You normally install a package once, right? So, okay, I know that I need a given package. I'm going to install that package to have that available to me. You can kind of think of packages as an app, right? So if you go to the app store of your phone and download an app, that's what a package basically is in our language. And packages normally are a combination of multiple functions that they have a certain purpose. So, so if you imagine like you would have functions that have arguments within them, but then a combination of functions that a given person decided to package together is called a package. So let's go ahead and install one package here that I did not ask you to install yet. That's called Tibble. So it's a package also from our studio to work with data frames. So if you recall, the name of the function to install a package is called install.packages. We have to open and close quotation marks, and we can, the name is Tibble like that. So if you run that, this goes to your console, and then, it's a very small package, so it should be easy to install. So these install packages I use only once. Maybe another option that I could use this again is if I want to update my package. Let's say I've installed it a few years ago, and now I want to update the package. I can just run again install packages. But that's it. You don't run it every time. On the other hand, whenever I want to make the functions of a given package available to me in my current RStudio session, I need to load that package. The reason for that is I don't know, I have thousands of packages installed because there's so many things available that you can do with different packages that I have a lot of packages installed. So if for every session I were to make all those packages available to you, that would make that session very heavy, and you may not even need a fraction of those packages for a specific project. So because of that, whenever we want to make a package and its functions available for this current R session, we use the function called library. So we say library in the package name. So here I'm giving in quotation marks. Interestingly enough, in the function install packages, always the package name has to be within quotation marks. For the library function, it doesn't matter. So this would work, but if you also did not give the quotation marks, it would work the same way. So when you run that library Tibble function, now all the functions within that package are available for me in this R session. If I close this R session, come back the next moment, I have to load it again using the library function.
Just give me a warning on that. we can install it.
So when you run the library table, it doesn't,
And it did it on the install.
okay, but
Install packages, table it says is not available for our version 3.3.
huh,
And unable to access index for the repository.
okay, let's check that after class, but yeah, it may be something with our version. But yeah, we'll look into that. Okay, so the next thing here I want to do is create a data set based on some of you in the class that we're going to first create that data set, and then we're going to play with that data set a little. So this data set is called intro. What I want to do here is, so, okay, let me take one step back here and tell you something. So we used the function DataFrame before to create a data frame. And if you remember, we gave the column names and we gave values within those as well. If you see, we could again use the data frame function to create this new data frame, but I want to show you a different way. And the distinction between the data frame and the function we're going to use next is that a data frame, you have to give it a column, and then all the values of that column should be followed here. And then another column name and the values will enter that column, and so on. I want to use here a function called, so if you go back to this intro, let's give it the assign symbol. I want to use a function called, oh, you know what? I think, let me check, Doug, on your code now, because this function that I'm going to use is actually from the Tibble package. And so if you don't have it, you're not going to be able to run that. Yeah, so your R version is from 2017. I think you're gonna have to update your R version.
Which, the R Studio or the,
So the R itself.
okay, I downloaded the one for Mac, the only one that said,
Um,
don't know why it would be. Just that's the thing.
yeah, this is the 2017 version. I'm not sure why you needed that. Yeah, but I think it's because of your R version, that package is not working.
The first one I put yesterday, for the R wouldn't download, I had to put it said it wouldn't want to.
Do you have, what is your Mac license? So maybe that's why, so maybe we can try this one here.
I think that's the one that I had.
So let me, we can check on this after class,
Okay.
to make sure that you get the right version and I can install.
I can try to get download. I have a class right after that.
Okay. Okay, no worries, 'cause, I mean, you're not gonna be able to follow this next step, because the function needs that package. But I think, yeah, we should definitely look into installing that. So for those online, we're just troubleshooting some software issues here. Oh, yeah, so, okay, so I just want to read this out loud because I think it's also a good learning moment. So the issue here is, so this is what you typed. Let me show so everyone else can see. So you typed install packages tipple, right?
This
Or
one,
or
yeah.
maybe the library. So yeah, you did install it properly, but on the when you were loading.
Yeah.
Oh no,
Yeah,
it,
it just
it does. Let's see. All right. Okay. Yeah, there we go. So yeah. I mean, this is just a warning. It's not an error. And that's a good thing as well to tell to others. So one thing in R is if you get a warning, that's okay. It's just letting you know something. You do, so you don't really have to worry much about warnings, even though they may come in red and seems like something big is happening. But if you get an error, that's when you have to worry about. So if it's just giving you a warning of something, it's normally okay. It's just for your own reference, but it's not going to impact. Okay, so make sure that you all install Tibble and then you loaded Tibble by using the library function. This function called Tribble is from the Tibble package. That's a mouthful. And the way that it is used to create data frames in R as well, it's a little bit different from the data frame function for the following reason. The way that Tribble works is you basically almost delineate your columns as if you were in Excel, sort of. So the first column here I want to say is name. You have to use to tell it that's a column name, you give it this tilde symbol, and so you say tilde name, add a comma, and then tilde height, add a comma, and then tilde, the last column is favorite crop. I just want to call that fav crop or favorite crop, and then you add a comma. So now you can hit return to break the code. And what I want to do is basically ask a few of you your name, your height, and your favorite crop, and we're going to together create this data frame that then we're going to be exploring, especially with some plotting functions. Okay, so let's start maybe here with Athens. Any volunteers to fill in this data, to tell me your information? No volunteers. All right.
Ujjwal, UJWL.
Okay, Ujjwal. Then I add a comma. Your height 5'8". Okay, so do you know how much that would be in meters or centimeters? Okay, because I mean, if I put 5'8" is, well, we can put like 5.5. Yeah, we can do 5.8. It doesn't really matter as far as that's concerned. And then what's your favorite crop? Soybeans. Okay. So if you see here what I did, and please do this on your side as well. So the first value under the name column was Ujjwal. I gave that within quotation marks because it is a word, is a character. The height, I gave it as a number, so no quotation marks in the number itself. And then soybeans, also quotation marks because it is a word. And after each one of those values, I gave it a comma to separate them. After soybeans, I'm going to give a comma again and hit return, so we can add our next participant here. Let's see, anyone online would like to share your information?
Yeah, I can do it. With
All
our
right.
Vinicius.
So Vinicius, please everyone go ahead and also type on your side. All right, Vinicius, what's your height?
Well, in meter is 175, but I think in feet it's gonna be like 5.3, if I'm not wrong.
Okay, I think it may be a little bit more. I think it's gonna be, well, let's put 5.5. I think that sounds fair.
Sounds good.
Awesome. What's
I would say soybean, but it's already there. I go with corn.
good? Awesome. Corn. Thanks, Vinicius. All right, so everyone, please go ahead and do this on your side as well. I do want a couple more people in here. So maybe let me ask someone from Tifton on the Tifton class.
Clint,
Can you say that again?
Clint,
Did you say Matt?
Clint, CLINT,
Clint. Sorry, Clint. All right. What's your height?
5'10".
5'10". I'm just gonna use a dot here. So this is not actually 5'10", but you know, for the sake of this exercise, that's gonna work. What's your favorite crop?
Peanuts.
Peanuts. Awesome. Thanks, Clint. All right, so please go ahead and fill this in. Remember to, if it is a word, it has to be within quotation marks. Remember to add the commas after each value. And now we're gonna get one more person here. So what about someone here from Athens again? Yes. Sandes. 5'8". Peanuts as well. No worries. All right, perfect. Okay, so I'm gonna just give a quick moment here for you all to catch up with the code in case you need to. Again, remember to have your commas. If you're missing a comma, that may be the easiest or the most common issue that you could have in your code. If you just come here, if you already have the code ready and you run it, so have your cursor anywhere here and just hit command return. It should, if you got your commas in the right place, everything right, you should not get any errors here. If you did get an error, watch out. So I just want to make an error myself here just so you see what would happen. So let's say if I forget one comma here after peanuts, and if I run this, it's gonna throw me an error. The error is somewhat explanatory, right? So it's saying unexpected string constant in clean 510 peanuts. So it's giving me some hints of where that is. So it's happening between peanuts and Sandes. So happening somewhere here. You see that also on the right, there's an X value showing me that it says expected comma after expression. So it's giving me hints that I'm missing a comma right here, right? So if you did get an error, try to troubleshoot that way. Also make sure that you have the closing parentheses here at the end that closes the function triple. Okay, so anyone needs help?
Yeah, I need some help.
Yeah, go ahead.
Uh, ask what is the sign in front of name, height, and save crop. I think I'm unable to find it and write it. That's why there's an error in my code.
Yeah, so that's called tilde. Let me paste that in the chat so you can use it. Yeah, I just pasted that in the chat so you can copy and paste into your code. All right, was everyone, well, I guess one way to know if you were able to successfully create it is, first off, it appears on your environment, but also if you run the word intro, you're gonna see this data frame below, which it has 3 columns. So it is a table of dimensions 4x3. So it has 4 rows, 3 columns. So we see here name, we have the 4 names, the 4 heights, and the 4 favorite crops. Does anyone need help? So we're gonna need this to work. I know, Doug, are you installing the new version?
Yeah, I'm just, updating my computer right here, so.
Okay,
So I'm by the next class, I'll have it.
okay. Sounds good. So besides Doug that is updating was everyone else able to get here, or does anyone need help?
I can't need help.
Hmm?
So I said the unexpected string constant in F. That's the error I get.
Maybe double check if you use the tilde in front of all the three columns and if you have a comma between them.
Yeah. Let me see.
All right, question.
Yes.
So I just know, I realize it doesn't make a difference now, but we just noticed it changed mine from 510 to 5.1. Would that make a difference if you were trying to run, like numbers that actually matter? If it would change a 10 to a 1?
Yeah, so in this case here, because I'm using it's like 5.1, right? In this case, it would not make a difference. But let's say if we were doing this, then it would. Right, it's just because as a part of a fraction, if you have zeros to the right, it's not gonna make a difference. But if it's not, if the zero is not coming as part of a fraction, then it would, right? Because imagine now it would be the difference between 51 and 510. Right, but that's a great point, great question. Yeah, so it's going to be interesting because when we make a plot of this, you're actually going to be very short, I guess. But it's just an artifact of how we're coding feet into, I mean, if we were using, fractions of feet, so 510 would be maybe like 5.9, perhaps, right, of a fraction. So maybe that would be, yeah, I think that, let me leave it as 5.9. Maybe that's a better way of having your height closer to what actually is.
Okay.
All right, so Rolando, did it work?
Then,
No?
so I have the error said unexpected string constant in F. The name list number is on quotations equal A numbers.
Do you want to share your screen for
That's
us
the
to
error.
take a look?
Yeah, sure.
I think I need to give you
Uh,
rights. Just
okay.
yeah, okay, you should be able to now.
Can you see it?
Yes. Okay, so for some reason, I think you have a lingering issue from above that is kind of perpetuating through your code. So can you just keep going up a little bit more, like on your script? I think there's something. Yeah, I think it seems like you may have maybe right there.
Is it this one?
So what it seems like is that you have a quotation mark that's unmatched. It looks like it may be, so you have a quote, so on line 70, you have a quotation marks after B. And I think that quotation mark is messing up everything after that. So line 70, you see like on the end of that line, you have a B, so numbers equals to B, and you have a quotation mark there. Delete that and replace it with a comma because you wanted a comma there. Yeah, so now I think.
Run it?
Yeah, you can run that. Let's see if that works. And
It's still giving me an error.
okay, so another thing. So if you look, this is, even though this may seem like, I mean, the people that are not being helped may be thinking, oh, man, and they're just here watching, but this is actually a really good exercise because you all are going to run into issues. I run into them daily. So it's a good exercise for us to troubleshoot something together so you can kind of, get some hints on how you would troubleshoot. Okay, so let's look at this. Let's first look at your error, right? So it says unexpected string constant in F. So it's showing you the function and giving you some hints. If you notice on your left side of your script on line 70, it has a red X there. So it's showing that the issue is there. So if you click on that red X on the left, can you see that? Yeah. So unexpected token numbers. So there's something going on there. So the error is not very clear cut. But before I tell you what it is, let me ask if anyone else can spot what's going on here. Yeah, so we have a few people here, Nathan, saying you're missing a comma. So if you see, so number equals A, you should have a comma after A. So between A and numbers, there should be a comma. Yeah, and that should fix it. So now if yeah. Yeah, so now everything else should work from that point on. Because I think, so there were a couple of things. You were missing a comma and you also had an extra quotation mark that was unmatched. So there was no, you were opening quotation marks, but not closing, which then makes all of your future quotation marks to be mismatched. Yeah, so here, let's see. Yeah, so if you, I just want to point out, just so you see as well, on line 99, you're also missing a comma after the true. And that shouldn't affect anything after it, but it's just to let you know. Okay, so let's get to your intro now. So intro, get a tribble, name, height, favorite crop. You have commas, you have the tildes, you have your name, comma, your height, turf grass. Okay, so on turf grass, if you see, there is two, yeah, there you go. So now you're good. So if after that comma there, you just hit return to break the code and add a few more people. Okay, so if you just have your cursor, yeah, right there, hit return, hit enter. Yeah, and you can hit enter another time just to make it easy for you. So go up one line and then you can keep writing the other names. No, sorry. So you want to hit return and have the parentheses in the line below.
In the line below?
Yeah, so hit return, enter right there.
Here?
Now just go up, but without taking the parentheses with you, just the cursor up to the line above. Yep, and then just keep writing similarly as we were doing before, and it should be good. So now it would work. All right, so I think this was, a great exercise because especially, if you're new to R, there's going to be a lot of mistakes that we're going to do. That's common, that is expected. And it was a good way for us to just troubleshoot this one. Okay, I will, if you can stop sharing, Rolando, I'll share mine again. And while you catch up, I'm just gonna show up here. Okay, was everyone else able to get to this point? If you were not, speak up. If I don't hear anything, I'm gonna assume so and keep going. Okay, so Rolando, while you, if you want to, I mean, you can just make up some names and numbers if you want. Doesn't have to be these ones. It's just that this was a way to get us all kind of talking. But on your side, if you just want to pick up some names and numbers and heights, you're welcome to. There's going to be an assignment at the end of this class that then you're going to need to have these. But no worries. You're gonna have some time to catch up with the video.
Yeah.
All right. Oh, sorry. Did you have something to ask? No.
Just say.
Okay. All right. So so we created this object called intro. Now let's check its class. First thing I want to check is the class of it. So if you remember, we use the function class and give the object name. The object name is intro. So if you run that, you see that it comes back to us as a TBLDF. So TBLDF is a data frame that is in a tibble format. It is basically a data frame. A tibble is a data frame. It just has a few different properties. So the way that it prints is different. So if you notice here, when we print a tibble, it gives us like how many rows and columns it has. It even gives us the class of the columns in here already. So CHR stands for character, DBL stands for double, that also means numeric, and CHR again, character. So it just gives us, a tibble is a data frame that just gives us more information when printing. So really, that's all that a tibble is. And then also is a data frame type. So these are all the classes of this object that we call intro. Okay, so next thing I want to do here is get a summary of intro. So this is going to be a very common function we're going to be using in class. Every time you read in the, so right now we're creating our own data frames in R. This is going to be the only time that we do it. From this point on, we're going to only be reading data into R and a lot more complex data, right? We're working with something very simple here. And so every time you bring in data, it's always great to check a summary of that data, because a lot of times there may be issues that you cannot find just by looking at it. You have to have a summary to help you. Let's get a summary of this intro data. It prints below it. So notice what it says here is, for each one of the columns, it gave me a result. If you notice, for the columns that were a character, so the name and the favorite crop, it's just giving me that it says that it has a length of 4, so it has 4 values, and it kind of stops there. It's not very useful. For a numerical variable, so the height variable is actually giving me a statistical summary with minimum value, first quantile, median, mean, third quantile, and maximum. This is very useful, because if you bring in, let's say we're going to be bringing in data sets for yield, for example, that have 50,000 observations. It's impossible for you to visually assess if the data is of good quality or not. So we use a summary function, and then if it comes up that you have a yield of, I don't know, 800 pounds per acre of cottonland yield, that is pretty much, well, let me see, I'm thinking, no, that is, that, yeah, we can get that. 800 pounds we can get, but let's say 8,000 pounds of lint per acre, it's very impossible. You're not going to get that. That's not a biologically possible value. That you may have just a data entry error, or maybe something happened, and you can catch that when you look at the summary. Because if your max is really something that is not biologically possible, then you can catch that here and then address that before you do anything with this data. So summary function, a very important one. We're going to see a lot of that. Okay, so a few other things I want to do here and show you the functions. So for a very large data set, there's a function called head. So if I say head intro, it's going to give me, I think by default is the first 6 rows of the data. Of course, our data set only has 4, so that's not going to help a lot. But this head function has an argument called n, where I can say, well, how many rows I want it to show me. I want to say n equals 2, just so you get the concept of what head does for you. So it's just showing me the first 2 rows of this data set. Again, if you have a very large data set, this is helpful for you to at least, let's say you have a data set that has 1 million rows. You don't want to print that, or you don't want to have 1 million rows printed on your screen. So you just want to have a hint of what that looks like by looking at the first rows. You use the head function. Similarly, there's a function called tail that does the same thing. So let's say, give it the object intro and also say n equals 2. The difference now is that tail gives you the last observations, in this case 2, because I'm asking for only 2. So it shows me the last 2 observations. And just another reminder here is, if objects are made up of components, so for example, a data frame is made up of multiple columns, a list is made up of different components inside the list, you have a class of the object, but you also have a class of each one of the components. So the class of intro, like we did before, is a tibble or a data frame. But now if we ask for a class of intro $, favorite crop, that's going to be different, right? It's going to be a character class, because now it is a class of that specific column inside of it. Okay, so we're almost getting to the end here. The next thing I want to show you is how to sample a data set. And I want to make this very clear that what I'm going to show you now is probably not what you're gonna use to simple data set moving forward. However, it is the default way or the original way that was done in R. It is the way that's done in Python for a lot of time, a lot of things. So I do want you to be familiar with that way of doing it, even though we're not going to be using this, we're going to be using more intuitive ways going forward. So let's say that I want just the first row of this data set, of this intro data set, right? I just want to print here intro again so you see it. So let's say if I just want the first row here, so the data for Ujjwal. The way that I would do that is right after the intro, I would open and close brackets. And this, inside of this bracket, it accepts two positions, an X, comma, and a Y position, X and Y. So X here would be the row position, Y would be the column position. So if I just want the first row, what I would say is just put a 1 right here, and then leave this Y space empty. So by doing that, if I run this, it returns me just the first row. So all the data, all three columns, all three pieces of information from Ujjwal. Okay, so if you go to the next point there, the first column only, if I do intro, and I use this concept again where X, comma, Y, where X is the column position, X is the row position, Y is the column position. What would you do here to get the first column, if based on what you just learned above? Like that? All right, so let's try it. Yep, that's it, right? So we're basically saying that we just want the first column, and the first column was name. So notice how now we got all the names or all the values within that first column. Yep, that's exactly it. Okay, next example here is, what if we want rows 1, 2, 3? So rows 1, 2, and 3, and columns 1, 2, and 3. So this is a little bit of a different one that I want to show you first. So every time you want a sequence in R, so if I want rows 1, 2, and 3, that's a sequence, we can use the colon notation. So 1, 2, 3. So rows 1, 2, 3 is specified like that. If I just run here 1, 3, it unfolds that into the numbers 1, 2, 3 for me. The same thing if I wanted something like 1 through 10, same way, right? So if I want rows 1, 2, 3, I can use that notation on the rows, and then columns 1, 2, 3, I can just repeat that same notation, 1, 2, 3. And then if I run it, notice that now I only got the first 3 rows. So the last row in our data set was Sandes. He's not here. And also I got the 3 columns, which, I mean, we only have 3 columns anyway, so it gave me all 3. Okay, so now it's a little bit of a twist there. What if I want rows 1 and 3? So I did not want 2. I just want rows 1 and 3 and columns 1 and 3. Let's get that started here. Let's see. Anyone has any guesses? It doesn't have to be a right guess, but I just want to see if you're thinking through along here. So based on what you learned until now, how would you specify this? Let me ask someone online. Vinicius, what do you think? How would you specify rows 1 and 3?
Oh, that's a good question. 1 and 3.
Mm-hmm.
I would say dot.
You mean this?
Yeah. 1 like dot 3. Something between like 1 and 3.
Okay, so let me help you out here. So because we want 2 numbers and they are not in sequence, we're gonna have to give it 2 numbers, right? So let's say we need to give 1 and 3. However, let's say if we just wanted rows 1 and 3 and then all columns, if I run this, it's not gonna work, because it is expecting that the comma is separating the X and the Y position. So it's thinking 1 and 3, and then, so it's not doing that So how can we combine these two numbers to say these two numbers are on this first position here, on the rows position? Any guesses? C, right? Yeah, so Ujwal said use the C function.
See?
Let's try that. So if you use the C function and we kind of like wrap that 1 and 3 into the C function that stands for concatenate. Yeah, so that works, right? So the C function works. So we're giving the 1 and 3 in the row position. Then this comma is separating the row from the column position. So we just repeat here C, 1 and 3. So we get only the rows 1 and 3 in columns 1 and 3. Awesome. All right. So next thing, which I think is going to be a cool topic here, is let's make some plots. I left you the code there already. You can go ahead and install. If you don't have ggplot2 yet, install ggplot2. And then if you already have it, you can skip the install part, but you need to load it using the library function right there. Just going to give a quick moment here. And while you all install, if you need to, I just want to explain something. So in R and in any language, there are different ways of doing different tasks. Plotting is no different. So originally, so if you think of making plots in R, there may be 3 different schools, I guess, of plotting in R. One of them is called base R. So if you were a function called plot is a base R function. It was highly used until a certain point, but it was not very intuitive. It did not have a syntax that transferred between different plotting functions. Then there is another approach called lattice, because there is a package called lattice that is really good for plotting. However, in my opinion, and I think in many people's opinions, the best one is ggplot2 because it's very intuitive, as you're going to see here in the exercise. It is also very flexible. So we're going to be using ggplot2 for 90% of our plotting in this class. I want you to be aware of that. And the main reason for that is if you run into an issue of plotting, how do I make a bar plot in R? If you ask that to Google, you're going to get answers that may be ggplot related, maybe base R, maybe something else. If you ever run into an issue of plotting and you're asking Google for help, you need to explicitly say in ggplot2 or using ggplot. That's going to get you the right answer because, again, there are different schools. You have to be specific if you're asking questions in Google. All right, so let me print intro here and just ask you all. I want you to help me here to think, if you were to make a plot with these columns, how would you do it? So let me simplify my question. First off, what column would you put on the x-axis? Well, let's just think about that. I'll just make a comment here. So, oh, I think I forgot to say, but in R, if you in your R script, if you want to write something and that's something to not be interpreted by R, you can use a hashtag or a pound symbol to or to comment off that part of the code, so it's not interpreted. So I'm just making a comment here that X is going to be which one of these columns here, name, height, or favorite crop, would you put on X? Say that again. Name, right? I think I like the idea of putting name there. So let's put name as X. What would you put on Y? Height, right? I like that. Okay. So let's start with that, right? So let's do that a plot in ggplot by where we do those 2 things. So to do that, we use a function called ggplot. So notice that the package name is ggplot2, but the function is actually called ggplot. The first argument here is going to be the data. So the data we're given it is called intro. And then the way that we tell R what goes on X, what goes on Y, comes on the second argument that's called mapping. So if you start typing, it's going to appear for you. I would just want to break code here to make it easier. So mapping, we give it a function that is called AES, that stands for aesthetics. So this is where we say what goes on X, what goes on Y. And if we are assigning different colors, shapes, anything like that, that's where it would go. So let's say here, if I just, so I have intro printed below here, just so we can see. Let's put X equals to name, and then add a comma there. And let's say Y equals to height. Make sure that you spell exactly how it is on the data frame. R is case sensitive. So if you write here uppercase name, it's not going to know what you're talking about. It has to be exactly how it is spelled on your data. So inside of the data that you specified there. So if you have this and you run it, you should have a plot show up on your right-hand side here. Well, I know maybe Doug is still working on that, but oh man.
And it's not, I don't have time to do that, but that wouldn't download.
Yeah, okay. Okay, well, yeah, let me know if you need help with that, if you get into any trouble, but yeah, I think once you have that updated, I think you should. Yeah. Right, and yeah, the video is gonna be posted. Okay, was everyone else able to reproduce the plot that I'm seeing here? If you were not, please speak up. Okay, I'm assuming you were, so let's keep moving. So if you notice here, R basically just made a canvas where it has height on the y-axis. It gave us already a range of values that are within our data. And it gave the name and the values of name as well on the x-axis, which is exactly what we asked it to do. However, it did not show the data yet. And the reason for that is because we did not tell it how to show the data. So if you think of it, there are a couple or a few different ways we can show this data. And I just want to ask, does anyone have any suggestions of like, and what I mean by how to show this data is, you want to show it as a bar, as a point, as a line, as something else. Anyone has any suggestions here? Eva, what would you do? A bar? Okay, let's do a bar. So to show a bar plot here, we would add a plus at the end here, hit return, and then start typing geom underscore. So geom stands for geometry, is basically the geometry that you want to show in this plot. If you just do a geom underscore and stops there and look at all the options that it gives you, there's a lot of different shapes that we can show data as in ggplot. And again, that's part of why it is so good, such a good of a package, is because it gives you a lot of flexibility. So so we could do a bar. I just want to propose we do a point, just because there are some things I want to show you here that a bar doesn't allow. So maybe let's try geom point first. And let's run that. Make sure that you have your plus in the end here. Make sure your parentheses are closing. And you have your commas in the right place. And you have a plus at the end here. So if you had all that in place, you should be able to see what I'm seeing right now, which is this point plot right here. So we see that for each one of the people in this data set, it actually just added a point wherever the height was listed. Okay, so I want to just print intro again, just to remind you that we still have another column here. We have a favorite crop column. How do you think that we could show this information in this plot? How would you add that as part of this plot? Let me see, let me ask someone online. Hejimar, what do you think? I don't think we can. Well, you're muted. Yeah, hey Jamar, can you hear us? Yeah, sorry, I cannot hear you. You're still muted. Oh, okay. Got it, got it. Okay, so let's try Kumar. What do you think?
Can you repeat me the question once again?
Yeah, so right now we have one variable on the x-axis, one variable on the y-axis, but in our data frame we have another variable that has not been used yet in this plot. That's called a favorite crop. How do you think we could show that variable in this plot?
I think we can add that with names, like with name we can put in parentheses
Okay,
whose have brought up.
we could do that, but can you think of a different way, I guess, of like a way to show directly in the plot?
I find it hard to speak. I mean, we can't go to z-axis and it is two-dimensional. Right now I am unable to think of that.
No, no worries. Okay, can anyone else? A factor?
I would say on the points. Add the fave car on the points. I think would works.
Oh, what do you mean by add that on the points?
On the points we have on the plot, add the fave crop together, like close to as a label. Can
as
be
a
one
label.
idea. I don't know if it works.
Yeah, we could do that, and that's something that we're gonna see in the future exercises. I guess let me propose something here and kind of help you think through this. So one way that we can add more variables and make a two-dimensional plot actually show up to 5 or even 6 variables. So you're gonna see a lot of this throughout the class. But to start very simple, one way that we could add this is by either changing, well, let me tell you one and then I'll let you think of another one. So let's change the color of the points according to favorite crop. Okay? So to do that, if you want to change a plot aesthetics like color or fill or shape or transparency according to a variable in your data set, you have to tell that inside the AES function. So let's go inside of the AES function right after height. Let's give it a comma, break the code just to make it easier to see. Now let's say color equals to favorite crop. Okay, so just to recap, I added a comma after height. I broke the line just to see better. And then I said color equals favorite crop. So if you run that now, notice what happens. It created already a legend for us. It assigned a color to each one of the levels that were under that favorite crop column that were corn, peanuts, and soybeans, and already colored for us. Right? And that all happened automatically just by saying color equals favorite crop. Another thing that we could have done here as well, well, I guess let me stop here for now and just leave it at that. So this would be our plot so if you notice now, we showed 3 variables in this plot, right? So one on X, one on Y, and one through color. There are other aesthetics components of this plot that we can add even more variables, and we're going to explore one of them next year. So if you come down on the customizing, oh, you know what? It's actually 11:09. So maybe we can stop right here and we can continue this on Friday. So our assignment is going to be postponed to Friday. That's when you're going to do it. It's a very simple assignment, so you don't have to really worry about it. Just please make sure that if you were not able to follow along in class today, that you do catch up before the class on Friday, because we're going to continue onwards. If you have any issues in the code and software, anything like that, let me know. I'll be glad to connect with you and help you out before the class. And one last thing before you go is I wanna come here on the GitHub, my GitHub repository of the class. I'm going on issues, and I'm gonna be taking your attendance on GitHub. So I'm gonna create a new issue called attendance, January 10th. I just created that. So please go ahead on this. So if you need a refresh, this is github.com /Leo M. Bastos 2024 PPA. This is our GitHub repository. Let me paste that on Zoom. My screen is stop sharing. What's going on? Okay, let me just come here on the chat and paste. So if you go there, there's going to be an issue called, if you go on this link, go on the issues tab, there's going to be an issue for attendance for today. Just drop me a note saying, I don't know, whatever you want. You can just say here, present. You can send me an emoji, whatever you wish, just so I know that you were here in class today and I can count that towards your attendance. And we're going to continue this exercise next class, and then get started with some other data analysis. All right, after you respond on the issue with your attendance, you're good to go. Thanks everyone, and see you next week.
I got it stuck at the end, doctor. Sorry.